Alright, let's go ahead and get started with this lecture video on specific heat capacity. This falls under Lesson 2, Calorimetry, in your notes. So as you follow along in this lecture video, go ahead and take some good notes and fill in some stuff. Alright, we're going to start off with defining what exactly is the specific heat capacity. So essentially you can think of is the specific heat capacity is most easily thought of as the heat energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, so let's think about this. So if you have exactly 1 gram of a particular substance, whether it's a compound, a molecule, or an atom or something, okay, if you have 1 gram of it, the specific heat capacity is the amount of heat energy that's required to raise the temperature of that 1 gram by 1 degree Celsius. We can also change degree Celsius to Kelvin. So specific heat capacity is often measured in change in 1 Kelvin as well. All right, now every single material out there has a specific heat capacity. So no two materials have the same specific heat capacity. By the way, the specific heat capacity is abbreviated or symbolized by CP. Okay, so whenever you see CP, we're talking about heat capacity there. All right, now we can determine the specific heat capacity with the following equation. Essentially, you can look at the specific heat capacity is equal to the quantity of heat supplied divided by the mass of the object times the change in temperature. And that will give you the specific heat capacity. All right. Now, going back to looking at specific heat capacity of different materials, usually metals have relatively low specific heats, indicating that relatively less energy is required to raise their temperature. By comparison, water has a relatively high specific heat, so it's going to take a lot more energy to added to a gram of water to heat it up by 1 degree C. All right. Metals, that's something you should just generally know about metals, that they have low specific heats, and water has a very high specific heat capacity. All right, so make sure you understand that. All right, now we can rearrange our equation to find specific heat. And when we rearrange it in such a way that we get an equation like this where heat, so we set everything equal to heat. So heat is equal to M, which is the mass, times the specific heat, times the change in temperature. When you use an equation like this, using the specific heat, mass, and temperature, you can actually determine the amount of heat transferred from one object to another using this equation. So this is a really important equation that you need to have memorized. We're going to use this equation throughout thermodynamics, specifically when we talk about heat transfer and calorimetry. All right. Now, here's the key. Basically, the mass is the mass of a substance, C is the specific heat capacity, and then the temperature change, which is the final minus the initial. And we always take the final temperature minus the initial temperature for the temperature change on that idea. All right, so again, memorize this equation because it's a useful equation, and not only to find the specific heat of a substance, but also to find the amount of heat that is being transferred from one object to another. All right, lastly, there's a table here in your notes You don't need to memorize this table other than one of these substances. I would like you to essentially know the specific heat of water, which I have highlighted. The specific heat capacity of water is 4.18 joules per gram degrees Kelvin or Celsius. Okay, so you remember I said that you can interchange Kelvin or Celsius because we're only going up by 1 degree here. All right. So looking at this comparison, you'll notice that water has definitely a very high specific heat capacity compared to these other materials on this table. The metals in general have very low specific heat capacities, and even glass only has 0.840 joules per gram degrees Kelvin in its specific heat capacity. Okay, so the only one I want you to memorize again for the quiz is water, the specific heat of water. All the other ones we will use just as a reference for problems or for other class room uses. Alright, so that is specific heat. Feel free to rewatch this video again, take good notes, and the two things that you really should memorize is the specific heat of water and the equation in order to calculate the amount of heat transferred. Alright, so that's it for right now.